Geometry lesson on medians, altitude of triangles. All right, guys. So let's get started. Um, Finding the balance point of the triangle. One of the ways to do that is actually to understand first what a median is, right? But before we could talk about that, the balance point is like, let's say you have, I don't know, you cut something out on a piece of paper or wood, uh, make a triangle out of it. There's a point at which, let's say, if you have a triangle like this, maybe I don't know, this point right there, that would be a balance point. If you put a pencil over this, it should be able to balance as long as you found this point exactly as you're supposed to, right? And way to do that is learn to think about median. The median of the triangle is a segment whose endpoints are vertex of the triangle and the midpoint of the opposite side. So that would be right there would be a median, right? So this point is a midpoint of the side AC, and opposite vertex creates a segment, and that's called the median. And the point of concurrency for the median is called centroid, and sometimes referred to as the balance point. All right, guys? Okay. So now I forgot to actually type that in, the centroid theorem, and I'm going to write it out for you like right now. Okay. Centroid theorem states that, here you go, guys, the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So what they're basically telling you is that in this particular case, this particular picture, BG is 2/3 of BD. Another way to put that is BG is twice the GB, because if this is 2/3, this is 1/3. So that makes BG twice as long as GD. Sorry about that. That should be D. Okay. There you go. And then I'm going to write out the rest. Okay. Let's see. AG in this case is 2/3 of AF, which means that the AG is twice the GF. And also we have CG is equal to 2/3 of CE. That also implies that the CG is twice the, twice the GE. Okay, guys? All right. Knowing that, what is my AG? We know that the AG is what, guys? 2/3 of AF, right? But what is AF? AF is 9, so that makes it 6. All right, how about GE? He's looking for GE. GE is either 1/3 of CE or it is 1/2 of GC, isn't it? Because GE is 1/3 of the whole length. So it is either 3 times that is equal to the whole length or twice that is equal to GC. I don't know which one, right? So the effective one here is this one right here, guys. Okay. Sounds good. All right. But we have length CE, so we have to go with this one, right? So 1/3 CE of 7.2 goes in 2.4. Okie dokie, guys. All right. So let's move on to the next set of questions. Okay. So find the coordinate of the centroid of the triangle shown below on a coordinate point. So it's much easier to do this when you have printed this out with a ruler. I don't have a ruler, okay? But we're gonna do this anyways, okay? So I need to find the midpoints of each. And then the way I'm going to count is it goes from 0 to 6, and it goes down 4 this way. So it goes 6 this way, 4 this way. So it must be 3 and 2 down here, 3, 2. Do you see that? All right. You don't have to do a long, protracted calculations. But the formula that we have, let's call this n, right? So n is midpoint of QR, right? If that's the case, you know what? Why don't I do this? Call this L. And then 6.4, let's call this M. Okay. So let let L, M, and N be midpoints of segments. Oopsie. You don't need to use the segments. The L is a midpoint of PR, and M is PQ, and that's RQ, comma, respectively. Okay, so you want to communicate with whoever is seeing this. So now, so that's why you want to have this let statements and stuff like that. Okay, so let people know what's going on. So L is the midpoint, and the midpoint formula is what? The average of X and average of Y. So that's 3 plus 6 over 2, and 0 plus 4 over 2. And that it means that L is going to be, okay, 9 over 2, comma 2. 4.5, comma 2. So there'll be 4.5 over 2 right there. Okay, so that's good. So we know that we could just connect it this way. Oopsie. There you go. There you go. All right. So let's now calculate M. And the midpoint of that is distance between point Q and point P. So that'll be the average of 0 and 3, which is, oopsie, 1.5, or just 3 over 2. Leave it as a fraction, right? And the average of the y's, which is 0 and 8, and that is a 4. So I just go out vertically 4, guys, like straight across, and I know that's what that is. You don't have to worry about the x in this case. And then let's go with n, and that's average of 0 and 6, and 8 and 4, right? So that'll be 3, comma 6. I said 3, but I wrote 3 over 2. Sorry about that, guys. And it goes across 6. Make sure that's 3. Yep, that's it. So if I connect these points like thusly, like that, it connects, right? Right there, right? So therefore, the centroid point is what? 3, 4. Okay, now let me make that a little tiny bit smaller so it fits nicely into the notes. There you go. There you go. And yep, I'm maybe this a little bit too small. Sorry about that. Here you go. And that way I can push this up a little bit to the side. It'll fit nicely. And that's nice underline right there. Underline, underline. There you go, guys. All right, are we good? Okay, let's move on to the next material. And we're going to be learning about the orthocenter today. Okay, something that's orthogonal is when they're perpendicular, guys, actually. Okay, so the altitude in this case is altitude of a triangle is a perpendicular segment from the vertex to the line containing opposite side. Every triangle has 3 altitudes. Altitude can be inside, outside, or on the triangle. And the length of the altitude is often called the height of the triangle. So if you have an intuitive sense of what a height is, this should be fairly straightforward, right? So if you have a, I don't know, triangle that looks like this, right? The height over here, that'll be the altitude. Right here, guys, that'll be the altitude, okay? So that would be perpendicular, and that would be A. Let A be the altitude, all right? Or you may have something that looks like this. That's right triangle. Then this side right here, guys, A is the altitude. So in the first case, the altitude was inside the triangle. The second case, the altitude was outside the triangle. And if you actually, this, you could tell this is obtuse, right? If you rotate it sideways, it may look like this, right? And then if you drop the height to the opposite side, guys, like this, that right there is the altitude, okay? Right there. Yeah, so altitude could be inside, on, or outside of the triangle. And the concurrent point of the altitude is called the orthocenter, right, of the triangle. It's the intersection of concurrent point of the line that contains the altitudes, right? Okay. So now let's try to figure this out, okay? First one says, find the orthocenter of the triangle by graphing the perpendicular line to the side of the triangle. The triangle, the vertices is 0, 0, 2, 6, and 8, 0. We rarely use letter O because it looks like a 0, but the only exception would that be, usually we might use it as a the origin, the point on the origin, right? Okay, so let's do this. This is a little tricky actually, right? For the first one is very straightforward, isn't it? So it goes straight down, perpendicular, because that's what that is. So that's very straightforward, right? So we got OQ, right? But how do I draw the other two? So that's the tricky part. Okay, so we're gonna have to go backwards. So what is the slope MQ? Slope of, sorry, I meant to say PQ is -1, isn't it? If you count, it goes down 1, right 1, down 1, right 1. Yeah, that's -1. So, and I need to go from here. So from slope here to here should be perpendicular, should be what? 1, exactly. Let's call that L, right? So let's call segment OL has to be 1. If that's the case, we know that the PQ is perpendicular to OL, right? Okay, so what I'm going to do is I'm going to start from here though. 1, slope 1 right there. That's how I do it. I start from the opposite side. So that's L and it's perpendicular. And I can see that that right there is the orthocenter. However, let's just try to do the other side just for the sake of practice, right? You only need 2, by the way, because we know that these concurrent points intersect at a single point, right? If you know that already, you only need to do 2 of them. But for the sake of exercise, how about this? We need to find something that's perpendicular this way. So what's my slope over here? And then slope this one is negative reciprocal, right? Slope over here is, it goes up 6 here, across 2, so my slope is 3. The slope of OP is 3. So if I'm going to call this opposite side, let's say, oh, I don't know, K, then slope of QK has to be -1/3, right? Then we could say that the OP is perpendicular to segment QK. So what that means is that I'm going to start from here and I'm going to go to the opposite side using the slope -1/3. So you go, so we have to go up. So I want to go left 3, right? So you go 1, 2, 3, up 1. See that? And then from here, 1, 2, 3, up 1. Okay, looks like I could do that and then go all the way to this point right there, guys. Okay, all right, and then that's perpendicular. All right, so by doing so, I found out the orthocenter is 2, 2. Okay, all right. We could do this using algebra, okay? And at some point, that will be a requirement. All right, so we did it just by graphing approach, right? So this is just graphing. Okay, let's use this using algebra. Okay, so now we were given, okay, this is approach number 1, approach number 2. We're given the information, and one of the segments was what? Let's call this K, J, K, L, M. Let's call this M right there, guys, okay? So we were given that information, right? So we're given that the PM, we're given PM, and that equation was x is equal to 2, because that's a vertical line, isn't it? So using the information that we have earlier, so instead of just graphing with this point, guys, using this information, and not the OL, see that? So we could say line OL instead, right? Segment OL is part of the line OL, right? My slope has to be 1, and the point that it contains is what, guys? 0, 0, right? So using the equation y minus y naught equal to m times x minus x naught, and that's the x naught, that's the y naught, and that's the slope. Plugging all the values, we know that the y is simply equal to x. And the intersection between this line and this line is what? So I got this equation here and this equation. I just plug it in. Therefore, y has to be 2. Therefore, this intersecting line is 2, 2. That makes sense, guys? Good. Now, let's operate under the assumption that we didn't have this information, right? We didn't have that information at all, okay? So let's forget about this, that we did this, okay? All right, now we need to find this line, okay? For the sake of exercise, right? That's Q, and the name I called this was K, right? So let's go line QK. And we know that the slope over there was negative 1/3, and it contains the point A0. And using this equation, guys, right here, let me put that over here. So we know that. Once again, this is the x naught, this is the y naught. That means that is y minus 0 is equal to negative 1/3 times what? X minus 8. That's what we have. So this is the equation number 1, equation number 2. But it says that y is equal to x. Okay. How do I solve that? We can substitute this into this right there, guys, which means that the x is equal to negative 1/3 x minus 8. We multiply both sides by negative 3, then negative 3x is equal to x minus 8. Negative 4x is equal to negative 8. That implies that. Okay, let me push that up a little bit. I just ran out of space. Oopsie, oops, what just happened? There you go. And then x is equal to 2. And this one says, plugging that back into this equation right here, guys, right? The xy has to be the same value. Therefore, xy is 2, 2. So the intersection is 2, 2. All right, guys? Good. Yeah, bringing back the old Algebra 1. So this goes to show you that there is no like clear distinction between geometry and algebra, in that at some points, though, one class, some topics could be done in either class, right? Right. And this kind of exercise could have been done, infused into Algebra 1 class or Algebra 2 class, and vice versa, right? Okay. How about this right here, guys? Why don't you guys go ahead and try to do this on your own, right? But I think this one you could draw this fairly quickly, can't you? Right? Let's just use this one by graphing, shall we? And we know that this is perpendicular, vertical. So from here, what's perpendicular to that is horizontal. It goes this way. Exactly. So one of the things you might want to do, just when you have an obtuse triangle like that, you just extend out one of the sides and just pull it out like this. And when a problem gives you a vertical or horizontal line, it's a gift. It really is. And then you go straight all the way across as long as you can. Okay. Now, the second thing I want to do is, you know what might be nice is to know this. What's my slope over here, guys? Slope of, what is this? Let's just zoom that in a little bit. AB. Okay. So looking at this, clearly it is going from here, up one, up one, up. Yeah, slope is 1. Exactly. So if I'm connecting to this point, I want slope to be -1, don't I? Which goes this way. Right. So the slope of AB, if it's 1, and if you want the altitude to touch at K, K is on AB, right? Call it CK, has to be -1, right? So what that means, by doing so, we know that the AB is perpendicular to CK. So from here, I'm going to go backwards like this, right? You touch that one right there. And what I'm going to do, I'm going to extend from this point, I'm going to extend it out all the way through and go straight through C, just like that. Okay. I think I just made a boo-boo, did I? No, I did not. Okay, let me just double check everything. So what is going on here? So we have something going perpendicular all the way across this way, -1, 1. And we have a point over here. And we just went, slope was -1, which is right there. Go all the way through 8. Okay, you know what? Let me just draw this a little bit more carefully because it looks kind of a little messy, right? So that's 1, 1, 1. I'm going a little at a time. There you go. See that? All right, instead of doing a long, messy line like this, and I got this one here. So I found that the intersection is like right there. Okay. All right. Yeah, because it didn't look right. So you got to be very, very careful here, guys. Okay. Right. So now, because of that, we could clearly see the orthocenter is 9, -1. Okay, guys? All right. Sorry for taking so long. Here we go. So now we have your turn. Why don't you guys go ahead and try this on your own. Pause the video. I'll show you the answer in a second, but you should really try this on your own. Okay? For 9 through 14, 9, 10, 13, 14, we could go with that in class. All right, guys? All right. I'll see you in the next video.